So in the last clip, we managed to get this page of the Supercar Showdown application to raise this internal exception. So again, this is the error-based SQL injection we're looking at here. And we managed to get this error to occur simply by appending a single quote to the URL. It's now been URL encoded via Chrome, but that %27 is the URL encoding syntax for a single quote. And in fact, it's this extraneous single quote sitting at the end of the internal exception here, which is the one that we've entered. Now, all of this begs the question, what's actually going on underneath? So what has caused this exception to be raised? To understand this, I want to jump over and show you what the query string looks like and what that's translating down to in the underlying database query. Let's start to break this whole request and query thing down a bit and see what's going on. So here's the query string that we had originally. So this one is perfectly legitimate. So the resource is cars by cylinder, the query string name is cylinders, and the value is V12. Now I've put V12 in red because that's effectively our untrusted data. So that's the stuff that we're manipulating and that you must always expect an attacker to manipulate. Because they can do whatever they like with it. It's just part of the URL. And likewise, any data from things like the request body, if a form is posted, or even the request headers are all untrusted data. So any of these things can be manipulated by an attacker and changed to whatever they like. So here's what happens. Cylinders V12. This then gets translated into a query like this. Now this is pretty basic SQL syntax. It's just the same sort of stuff as we looked at in the previous module. The real key thing here is again the text in red. So this where clause, where we expect the cylinders to be V12. Now you'll notice that V12 here is encapsulated in quotes. It's a string, and that is a specific data type within SQL Server. In the URL, everything is a string. It may then be typecast to an integer or a date or something like that, but in this case, it's been passed through to the database as a string. So here's what we did next. We added a single quote to the URL, so just off the tail end of V12. What happened then was that caused this SQL statement to look like this. So see how we've now got two quotes off the end of V12. Now this is no longer valid SQL syntax. And in fact, as far as SQL Server is concerned, we've now got an unclosed quotation mark. So basically everything is unbalanced. And that's exactly the exception that we saw bubble up into the web interface. Unclosed quotation mark after the character string, and then it had V12 with one single quote on the left and two single quotes on the right. So this is what caused the exception. And just as we saw in the previous module, when there's a problem with your query, SQL Server tells you. It tells you exactly what is wrong. Now, of course, this is meant for the developer, for debugging purposes. It's not meant to go back out to the public, because not only is it a nasty experience, but it also allows us to start exploiting underlying risks using error-based injection. We're going to look at that in more detail later on. For now, the important thing is that we know that there is an underlying SQL injection risk. So let's start to probe away at this a little bit. What if we change that query string parameter from V12 with a single quote to this? Now this starts to get a bit interesting, and it's interesting because of the way it translates down into the underlying SQL statement. That would cause our statement to look like this. So there are a couple of key things that are going on here. So number one, that V12 string is being closed off with the single quote that we passed in the query string. The next thing is we've passed an OR operator. So now we're actually adding another condition to our where clause. Now after the OR operator, we've got this 1 = 1 condition. And clearly, 1 equals 1 is always going to be true. Now, combined with the OR operator, it's effectively going to negate the V12 condition. It doesn't matter that we're looking for cylinders that are V12s, because after that we say, or if 1 equals 1, which again is always true, then return the result. So this actually fundamentally changes the nature of the query. It's no longer a filtering query. We're just going to get everything. So the final thing in this query worth noting is the double dash. And per the last module, we saw that this was the comment syntax for SQL Server. So that double dash in the query string filters down into the actual SQL query itself, and it cancels out that last single quote. So on that bottom line, everything in red is what's come in via the URL. So again, the untrusted data from the user. But what it actually means is that that last grey single quote never gets executed. It's commented out. And if it wasn't commented out, we'd have this problem of an unclosed quotation mark again. So exactly the error we saw in the error-based SQL injection just before. So this is the new query string value that I'd like to use for the cylinders parameter. Let's jump over to the browser and see what happens when we change that query string value to this. So here's what we'd run just before, and this was the one that raised the exception, because again, this %27 up here in the URL was just a single quote. So let me now enter the query string that we saw in the slide just a moment ago. So here's the whole thing. V12, single quote, or 1 equals 1, and the double dash comment syntax. Let's see what happens now if we load this page. Okay, so this is interesting. We have actually now got every single vehicle in the system. We've got everything from the 16-cylinder Bugatti Veyron down the end, all the way back up to the 6-cylinder Nissan GT-R. And we've got all of it because of the OR operator and the 1 equals 1 condition. It's always going to be true. It entirely negates this V12 requirement. Now there is actually a term for this. It's called a tautology. Let me show you what I mean by that. When we talk about a tautology, we're talking about a formula that's always going to be true. And that's what the OR 1 equals 1 does. So we can append that to a query and we can negate every other condition in the query because it always makes it true. Tautologies are a very powerful construct that are used extremely frequently in SQL injection attacks. And they can be used for everything from returning the number of results that you see on a page, all the way through to entirely circumventing password validation on a website login. And in fact, that is a really important one, and it frequently comes up as an example of just how malicious SQL injection can be. So let's move on and have a look at what that attack would look like. One where we get to log in as whoever we'd like. Let's go and check it out.